I'm Jordi Verkouteren and I've been working for VMM for over 15 years now. My main expertise is measuring and characterization of particulate matter. Within vacuums, my main focus was the PM data, so that's data validation, data analysis, and data reporting. The working principle of a PM sensor is quite simple. Particles are drawn into the sensor, they pass a light source, and light is scattered towards a detector. More particles in the sensor means more light onto the detector. Data validation is a process where we decide whether data is good or not. When you're working with low-cost sensors, you often find data that's strange or just impossible. Here are some examples of data that didn't survive the validation process. The first one shows a peak of a single sensor. That's not impossible, but when it only happens to one of the 5 units, it's probably something going wrong with a single sensor. Here's another case where one sensor gave a spike that was always on the hour or half hour. That's probably some sort of electronic interference, but we didn't find out what it was. Of course, it's important to know how often this happens. You don't want a sensor with crazy stuff happening all the time. And you also don't want to take these data points with you in the analysis, because a few outliers can really screw up the results. The report has 6 sensor chapters, where we look at time plots, correlations between sensor uncertainty, sensor reference ratio, and we also compare the sensor with the EU gravimetric reference. There is also a chapter where we investigate whether sensors behave different at different locations. That's something we looked at for one specific type of sensor, and it's got some pretty interesting results. Anyway, if you want to know what's in it, you'll have to read the report, or you can start by watching a 15-minute video elsewhere on the website. First of all, different types do give different results, and some sensors are clearly better than others. In general, the results for PM 2.5 were good or reasonable. Sometimes sensors do need calibration, but that's something we can live with. The results for PM 10, however, they were not so good, especially if you look at the coarse fraction alone. So that's the particles between 2.5 and 10 micrometers. All sensors we tested gave pretty bad results. Some even used a very basic algorithm that makes no sense at all. For example, the Honeywell, it just adds 1 microgram when PM 2.5 is below 25, and it adds 2 microgram when it's above. So it's just making up a number. We noticed that other locations can be more challenging for sensors, especially places with a lot of vegetation, where we see that the humidity is often higher. And high humidity makes particles grow by taking up water, and that makes sensors overestimate. We also noticed that the field results are quite different from the lab results, which just proves that it's hard to simulate real PM in the lab. So what are the most important conclusions out of this research? I think co-location of multiple units is a good idea to help you identify data that is just wrong. All sensors were bad at picking up PM force, and it's impossible to put a single number on a sensor. It's like asking what's the best tool or what's the best software. I think it's also very important to communicate clearly what these sensors do and don't measure. And PM itself is complicated. There's a lot of chemistry involved, and the sensors don't actually measure the mass of PM itself. So that makes it even more complicated. You have to understand PM, and you have to understand the sensors. Sensors have no idea about the composition of PM, and the composition does play an important role in how the sensor reacts to the particles. And for certain applications, the best sensor might not be good enough. The thing I'm most proud of is the collaboration with different colleagues at VMM, at ORAVM, and at TNO. From a scientific point of view, I think it's the focus on PM cores. That gives some new insights. So what would I like to try next? Well, probably further investigate how sensors can help people who suffer from wood smoke, to provide some sort of proof of the hinder. And maybe just for fun, put some sensors on a drone and do some 3D measurements and see what we can find.